Hello everyone. In this video, I will discuss about AC-DC rectifier based on single phase full wave uncontrolled rectifier. Bridge rectifier. In the previous video, we learned about center tap transformer rectifier. We know that that kind of rectifier they need center transformer, and it will costly due to transformer itself, and also it bulky. In this video, we will learn about bridge rectifier. So in bridge rectifier is more compact compared to the previous one because there is no transformer. It's just a diode only. We have four diode. Four diode. 1, 2, 3, 4. So we can see that the orientation of diode, the connection of diode is look like a bridge. That's why we call bridge rectifier. This one is just arrangement. We can arrange like this or like this, just in terms of arrangement. The connection is same. We have output is at this part. Output here is AC and input here is AC and output will be here DC output, V out. Same as the circuit. AC is here, output is DC. This one. Output in we know that for full wave, the output will be all the waveform will be in a positive cycle. We give input positive, output first positive. So the second input is negative waveform, output will be positive. This is what we call full wave. Both waveform will be converted to positive. Right. That's why we call full wave rectifier. In the half wave, we can see that just only half of the wave will be rectified. The next of the half wave will be eliminated. The output will be just half wave. That is half wave. That is full wave. Right. So we will analyze the full wave waveform in two sections. First section is from this is our input. We have input voltage source. First section is during positive cycle, which is from 0 to pi, and second section is during negative cycle, which is from pi to 2 pi. That is section number 2 and section number 1. Alright, so we will study the waveform of each component, waveform of D1, waveform of D3, D1, D4, waveform output current of the V out, output current, V out, I source, all the waveform will be studied in this video. We will start with section number 1. Section number 1, which is from 0 to pi. Before that, we need to erase all the alright. Section 1, positive cycle here from 0 to pi. This section. From 0 to pi. What happened is, let's say we put our voltage here, positive cycle. This one. The signal is sinusoidal, which is Vm sine omega t, sine wave. This one is positive cycle from 0 to pi. But just follow the arrow, same arrow with this one, same arrow, positive, negative. Current will flow from positive terminal, go to this junction. It will turn right and turn left. We can see that this D1 and arrow and flow of current same, means that D1 will be forward bias. So it will turn on. Okay, will be short circuit here. Short circuit. Okay. For D4, we can see that arrow current like this and arrow of diode. Yes. So it opposite. Opposite mean that D2 will be D4 will be reverse bias or open circuit. D4 reverse bias. Okay, D1 forward bias. So current will flow. There is no current here. So all the current will flow through D1, pass through D1 until at this point, and then current will go here and go down. Okay, again we can see that D3, the arrow of diode and arrow of current opposite, means that D3 will be reverse bias. Okay, so no current flow through D3 due to reverse bias here, open circuit. So all the current will go to the load. This one is R. Pass to the load. Okay. Before that, we just write D3 reverse bias, and current will go here, go here. D2, we can see that D2 will be forward bias. Okay, same arrow, so short circuit here. So current will go until this point and go back to source. Complete one cycle. Okay, D2 forward bias. That one is a flow of current. So now we need to we want to study the waveform, the response of each component. V out, D3, D2, D4, D1. Okay. First we go study V out. Okay, we can see that the current flow here, R here. So means that there will be developed V out like this. Okay. The waveform will be, the polarity of waveform will be opposite polarity of current. So waveform will be go up. Okay, what is V out? Doing KVL. Okay, KVL. Yeah, this loop. KVL. Okay, KVL. V out equal to Vs minus this one is D1, VD1, voltage at diode 1, and voltage at diode 2, VD2. Okay, we know that VD1 and VD2 is forward bias. D1 and D2 is forward bias or short circuit. Short circuit. Short circuit. So when they short circuit, it becomes 0 volt. So V out will be equal to Vs equal to Vm sine omega t. Okay, output same as the input. Okay, means that all the input waveform will go to output exactly same. Okay, from 0 to pi. Alright, that one is V out. Okay, next is VD1 and VD2. We know that D1 and D2 is forward bias. So for forward bias, short circuit. So when short circuit, 0 volt. So from 0 to pi, short circuit, 0 volt. Okay, diode here, diode at D1, 0. Voltage at D2 diode, 0 volt. Right. Okay, VD3 and VD4, we know that VD3 and VD4 is reverse bias. Both are reverse bias, open circuit. So there will be voltage there. D3 and D4, D3 here, D4 here. So voltage drop will be, here is output voltage. So we can see it's in parallel. Parallel means that, however, the polarity is different, so minus. So from 0 to pi, it will be opposite. Okay, minus Vm. Okay, for I0 is here I naught, we have V naught, so I naught is equal to V naught over R. We know that they are in the same line or same resistor, so they will be follow V out. Waveform will be same as V out. Okay, from 0 to pi. Okay, ID1 and ID2. Okay, ID1 and ID2 is I naught here. ID1 is I at diode number 1. We can see that ID1 is exactly same as I naught, and also ID2 is here. ID2 is here, so they are in the same line. Okay, ID1, ID2, I naught, same line, means that ID1 and ID2 same as I naught. Okay, from 0 to pi. ID3 and ID4, we know that D3 and D4 is reverse bias, open circuit. So open circuit means that I will be equal to 0. Okay, 0 ampere. Open circuit there. Okay, next is IS, source. Source is here, IS is here. So IS follow the waveform of input, waveform of the source, so same. IS will be sinusoidal from 0 to pi. Exactly same as the input sinusoidal. Right? Okay, that's all for phase 1, for part number 1 during a positive cycle from 0 to pi. Next we go to negative cycle at from pi to pi. Okay, here second stage. For that I need to erase. Okay, the next wave is a negative cycle. This is the negative cycle from pi to pi. From pi to pi. Okay, negative waveform as the input. So input will be negative input. So we just follow the arrow, same as the input, negative. Alright. Okay, current will flow from this terminal, positive terminal, go to this point. Okay, this part, current will go this part due to diode D3 will be forward bias, short circuit. Diode D1 reverse bias, open circuit. So D3 forward bias, D2 reverse bias. So current will go straight away, and then D1 is reverse bias. So there's no current here, or the current will go here. So all the current will go here until pass resistor, output resistor, then go until here. Okay, you can see that D4 forward bias, same arrow, so forward bias, short circuit until here, and then go back to source. Complete one cycle. D4 forward bias, D1 reverse bias. Okay. Now we check waveform. So waveform, current go down, so means that waveform will be opposite, like this. Okay, waveform will be like this. Current go down, waveform go up, polarity of waveform. Okay, become positive cycle. Okay, the input is negative. You can see here, our input is negative cycle, and then the output will be positive cycle. The amount is, okay, V out equal to Vs minus Vd3 minus Vd4. Okay, 3 and 4 will be equal to 0 due to forward bias, and short circuit. Okay. So V out equal to Vm sine omega t. Okay, V out will be positive cycle. Okay, positive. From pi to 2 pi. Output is positive. Our input is negative. However, the output will be positive. So first waveform positive become positive. Okay. Second waveform negative become positive. So we have pulsating waveform here. Two positive waveform. Right. So next is VD1 and VD2. We know that D1 and D2 is D2 and D1 is reverse bias. So for reverse bias, our voltage is will be same as the input. Input exactly same as the V diode during that angle pi to 2 pi. Okay, VD1 and VD3 and VD4 is forward bias. Forward bias means that short circuit. Okay, for short circuit 0 volt. So from pi to 2 pi there will be 0 volt at diode number 3 and diode number 4 due to short circuit, due to forward bias. Alright, how about I0? I0, we know that I0 is here. So I0 will be follow same as our voltage, their voltage. Voltage at V0, waveform positive. So current waveform will be positive. Same waveform with voltage. Okay, current waveform, sorry, this not this one. Actually from pi to 2 pi. So waveform will be same as output waveform, positive cycle. How about ID1 and I1 and D2? We know that ID1 and ID2 is reverse bias. So for reverse bias, open circuit. So for open circuit, current will be equal to 0. Current cannot flow due to open circuit. So current equal to 0 from pi to 2 pi, 0 ampere. Next is ID3 and ID4. Okay, we can see that ID3 and ID4, ID3 and I0 exactly same current, just a same current. IS also same current. Sorry, this one. Okay, IS current. Okay, this current ID3 go to I0, go to ID4. So means that ID3 equal to ID4 equal to I0. This one is from pi to 2 pi. Okay, at this stage only. Okay, it will follow same as waveform of I0 like this. Okay. Alright. The next is IS. Okay, IS. IS, you know, IS it will become here. So we'll follow waveform of the input waveform, voltage waveform. So we just follow voltage waveform. Okay, from pi to 2 pi. Okay, that's all for response of the each component during second stage, which is during negative cycle from pi to 2 pi. Okay. The next is it will follow just repeat same cycle for positive cycle. We just repeat this one, so output will be same. Okay, just follow repeat the first half. Okay, then second half we follow here, so it will continuous repeating because this is AC signal alternating, so it will continuous repeating. Okay, that's all for voltage the response of each component. So next we will study about the equation, related equation in bridge rectifier. Okay, first we need to delete. Okay, we know that the input is AC, output will be DC. Okay, this section output here. So first we study what is output DC voltage, or we call average voltage. is equal to area upon of period. Okay, our output is here, V out. So we have curve like this, sine wave, and so it repeat same curve. So we just we just derive the equation for 0 to 2 pi. And the others is just repeating. Okay, from 0 to pi, t is equal to pi, 1 over pi, from 0 to pi, Vm sine omega t d omega t. Okay, so what we have is 1 over pi Vm 0 pi sine omega t d omega t. Okay, 1 over pi Vm, this one will become 2. So we will have 2 Vm over pi. This is our average voltage derivation. Okay. Next is I naught, I out. I out is equal to I out average equal to V average divided by R equal to 2 Vm over pi R. Okay. One is average current. Next is RMS. So RMS, we know this one is V peak. V peak. V peak is equal to Vm. So Vrms equal to V peak square root 2 equal to Vm over square root 2. Alright, so it's Vrms. Next is output power. So the output power will be equal to V average times I average. Okay. V average is equal to V average is current, average current. Alright, I think that's all for our AC/DC rectifier, single phase, full wave, uncontrolled. Okay, uncontrolled because we use diode. Uncontrolled rectifier, bridge rectifier. Alright, that's all. Thank you very much. Bye bye.